You start recording once I start speaking, right?
Yeah.
Or you're still recording?
I'm starting.
Okay. So, given the rapid aging population, interest is actually growing in robots to enable older people to remain living at home. So this is a research area of today's guest speaker. His current research interests include robots, wearable computing, and human-robot interaction. He's an associate professor at the School of Electrical and Computer Engineering, and his research has been supported by several federal and state agencies, including the NSF, DOD, Oklahoma Transportation Center. Please join me in welcome Dr. Weihua Sheng.
Okay, so thank you, Dr. Nuama and Dr. Hiragu for inviting me to this seminar. I think I gave like a talk to the college, during that seminar organized by Dr. Bunting, and I believe Joseph was there, and I think he was one of the few audience that time, right? So I guess most of you have not attend that seminar. But anyway, so I would like to introduce you my research in elderly care and kind of like related to smart health and also robotics, right? So hopefully we can, if we have some common interests, we can discuss that later, and we can maybe do some collaborative research. So my title is ASCCBot. This is a robot we are building in our lab, and this is a robotic assistant for home healthcare industry. So I know your department is called industrial engineering management, like that. So that's why I put this industry in this title. Hopefully it's kind of related to your area. Actually, this is really a big industry. Home healthcare industry or healthcare industry is really a big industry, and the importance is even growing nowadays. So, okay, let me see. I have some problems. Let's move on this. Okay, so today I will talk about the motivation of my research. Then I will introduce you the called ASCC Smart Home Testbed and the robots we designed and developed in our lab. And then I will focus on the human behavior understanding and the well-being assessment. These are the two important topics in elderly care, especially in home environments. Then I will show you some demos through the video recording. Then I will give you the conclusion and the future work. So, the elderly population is growing in the United States and also worldwide. This is a kind of survey by the US Bureau of Census. Also, there's a prediction there up to year 2050. And you can see the population of elderly, old adults are growing constantly. And by 2050, you can see it's more than 100, maybe, 100 million, right? That's a huge population. So also you can see this is another prediction by 2034, the younger generation, the younger population will be less than the elderly population. So that means there will be a growing gap between the supply and the demand in terms of the geriatric workforce. So that means you have more people to be, taken care of than the people they can provide the care, right? So that's a growing concern for any society. So that's why, we need to think about how to address this issue, right? Now, what makes the things more, serious is that most old adults prefer to stay in the comfort of their own homes, because if you go to a nursing home or assisted living environment, usually it's expensive, and you kind of lose some independence, right? So most people like to stay in their own homes when they grow older. So you can see there's some challenges in independent living. I would say there are three main problems. First is the physical health. If you grow older, usually, you will have kind of chronic disease, all kind of problems related to the physical health. Second, you may have mental health issues because of social isolation, especially if you are living by yourself, or, especially during this kind of situation, the pandemic, right, further increase this kind of problem. You are isolated, you get all kind of, more emotional problems, social connection problems, and that will give you trouble. And that is called the mental health issue. And also the last problem is, you may have kind of emergency situations, right? Like falling on the floor, this kind of, or any medical, emergencies. So you need to be taken care of. If you are living by yourself, that's really an issue. So we try to develop smart home environments that will promote aging in place through the use of technology. So this is our goal. And we try to use new technologies, including Internet of Things, robotics. So the final goal is to develop a new environment, a smart home environment that can help people age in place. So that's our research goal. So let's look at the existing technologies on the market. Maybe you have seen this kind of technologies, like this kind of lifeline, or just like a button, you push if you fall, if you are sick, you just call for help through this button, right? So this is a very simple solution. It's not very intelligent. It may work in most situations, but in some situations, they may not work, right? Then also we have seen more and more smart speakers in home environments, like the Alexa or the Google Home. So these are smart speakers, but they are more like passive listeners. They don't initiate a conversation with you. They don't monitor you. So those are the current technologies on the market, right? But Alexa actually is a very interesting product. That means people are willing to accept those kind of voice-activated smart devices in their homes, right? But of course, there will be privacy concerns. And also, there are many robots, either in the market or in research labs. So here I have some pictures. You can see we have those pet robots, especially the one on the lower left corner. That's a parrot robot developed by some researchers in Japan, and this already on the market. So these kind of pet robots provide companionship to old adults when they age in place. But they are still not very intelligent or very smart. And then we have seen these kind of social robots. So the first one is called a Gebo. So this robot was on the market a couple of years ago, but I heard they kind of closed the service due to the low sale performance. But I don't know, maybe someone told me, they are going to restart this project, this program, and they try to resell this possibly. But the main problem, I think, is still the intelligence of the robots. They are not smart enough to take care of old adults. And also you have the competition from Alexa. So this Gebo robot cannot compete with Alexa. Alexa is so cheap, but it can do most of the things this robot can do. So this robot is mainly a smart speaker, but plus some, body movement, expressions, so to make it look like a robot, but it's still not very intelligent. So that's why we need to further improve the intelligence of this kind of home service robots to make them, really possible for home elderly care. Then we have seen this kind of robots mostly in research labs. So there's a growing research interest in home service robots, I call it social robots. So also there's research in smart homes. Like here we have seen some smart homes in some research labs. One is from the Georgia Tech. The first one is from Georgia Tech. The second is from U of F, Florida. So they equip the smart home with many sensors, distributed sensors, and try to understand the behavior of the old adults. But to fully equip the house with all kind of sensors, it's expensive. You need a lot of maintenance and repairing kind of work. So we try to focus on some research challenges fundamental to this problem. First, I think the first thing is we need to monitor the old adults, right? If you want to take care of this old adult, you should be able to monitor in terms of the daily activities, what they are doing, when they are doing what, this kind of thing. Second, you need to be able to monitor their physical health. And of course, there are many commercial products you can use, like blood pressure monitor, EKG sensor, ECG sensors you can use. Also, body temperature, those kind of vital sign sensors you can use. The third is mental health. So how do you monitor the mental well-being or the social well-being of this old adult, right? So we try to do it in an unintrusive, elder-friendly way. So that's the key. You don't want to, ask them to wear like many sensors, right? Or you want them, the robot is kind of very intrusive. People will not like it. So we need to do it in an unintrusive, elder-friendly way. And that is very challenging. And the next is how to deliver the healthcare services, right? So the first is to understand the human, and the second is to deliver the healthcare services to the old adults if they need help. So that includes healthcare literacy, like telehealth, reporting, those kind of things, or consulting. And the next is intervention. So really you can provide the service and deliver the treatment to the old adult. So those are the two major challenges. And my research right now is mainly focusing on the first part. But the second part, of course, it's more challenging than the first one, right? Also, you need maybe approval, like FDA approval. This is really like not that easy to do this, right? But we have started with some simple intervention, like a medication reminder. We try to implement some functions on the robot, which can provide a simple intervention. So this is we call it a pie chart. This pie chart describes the core capabilities and the skills of the robot we try to develop. As we discussed, we have three main issues. The first is monitoring. So we have three major pieces. Monitoring is the first one. The second one will be, I would say, healthcare literacy. And the third part is intervention. And corresponding to the monitoring, we need to monitor maybe the environment, the physical health, the ADL. ADL means activities of daily living, like he's cooking, he's eating, he's using toilet, like that. And then the last piece is the mental health. Then the second piece is the healthcare literacy, including telehealth. So you can connect to the doctor's office through the robot, and you can use the robot to collect data and report to the doctors. Also, you can do some translation. We find we need some kind of translation service if you have some like in-home nurse, they want to talk to the old adult. They may have some language barriers, so we need to provide this service with the robot. And also consulting. It's more like a, medication Wikipedia, right? So you can provide the medication information if it's needed. Then we have the last piece, the intervention, like medication adherence check. So the doctors can, give the prescription, and the old adult will try to follow that, right? But they usually forget it. So you need to provide this kind of medication adherence. And also we can do cognitive fitness, like a training of the memory, training of the cognitive fitness. We call it cognitive fitness, right? It's more like a training, daily training of your cognitive capacity. And then we have the health coaching and even mood management. We can, cheer you up. If you are kind of sad or depressed, the robot can tell you a joke like that. So this is the piece. This is a pie chart we developed, and we hope we can develop the robot based on this pie chart. So now this is the concept of our environment. We try to introduce a robot, then we have the kind of simple sensors, right? But we try to eliminate or maybe reduce the infrastructure in the home environment, because we mentioned that it's very expensive to maintain a home sensor network or infrastructure in the old adult's home. So we try to focus on the robot and the wearable device, right? But in our preliminary study, we still have this infrared sensors, those cheap sensors distributed in the environment. Then you have the cloud environment. You can, connect to the cloud, and also connect to the caregivers. So this is a concept, and we developed this test bed in our lab, which is in the ATRC 321 now. So if you are interested, you are welcome to visit us. So here we have a wearable smart suit. We call it smart suit or smart garment. So this is actually developed. This was developed based on a smart health project funded by NSF. So we developed a smart garment to collect the vital sign data from the human body. Also, we have this robot. So this was developed based on a National Science Foundation project as well. So this robot is a mobile robot. It has speakers, microphones, screens. So it's like a companion robot, or we call it a home service robot. Then we have called infrastructure, experimental infrastructure. So we have a room, a smart home in the lab environment, but we cannot get the real sound like a toilet flushing. We don't have a toilet, so we try to mimic the sound through a simulation system called a sound simulation system. Then we have the motion capture system installed in the lab to capture the ground truth of the human activity. Also, we have our own server, a cloud server. We call it a private cloud server. So this mimics the public cloud, and then you can connect to the healthcare providers. So, so this is the picture of the environment, and you can see we build up this small. It's a really small environment. It's just a one-bedroom apartment. My student, he built this. He created those mock furnitures, simulated furnitures, or appliances, right? But we have some real furniture as well, like a bookshelf. We even have a single bed there with mattress, and we have a simulated toilet or bathroom here. So we have 2 robots, and we have some wearable device, smartphone, and also we have the infrastructure, like the motion sensor, the OptiTrack motion capture system, like that. So this is the floor plan of this environment. So this is our playground. So this is our robot. It's a close-up look, and you can see we have speakers, we have smart. It's a laser rangefinder. It's a small computer here, and this is called Pioneer Robot. I purchased it using my startup many years ago. So we built on top of this a frame here, and we have touch screen, 3D camera, some pan tilt unit here. So this is a microphone array, and this is a very cheap solution. We use called a PS3. I hope you know that, PlayStation, right? PlayStation PSI microphone, and it's very cheap, just 20 bucks. Then this is the tabletop version of our robot. We call it ASCCBot, and this does not have a base to move around. Why we don't do? Why we develop this one? Because the mobile version is really kind of risky to old adults right now. If they bump into the old adult, you may create a problem, right? So that's why we use the tabletop version right now, mostly. So this robot has a face, and it's a simulated, right, face. Then we have a 3D camera here, microphone on top, and the robot body and the base, and the robot head can move like left, right, up, down, like that. 2 degrees of freedom. So, so we introduced the robot and the smart home environment. So now the next topic is, we try to understand the human's behavior through kind of non-intrusive way, right? So non-intrusive means you try to protect the user's privacy. We know cameras always cause concerns, right? If you use a lot of like images or videos to understand the human's behavior, that's really intrusive. So we try to use audio. So this is our auditory perception framework. The basic idea is, the robot has the microphones to collect data, the sound data from the environment, and hopefully you can separate the audio with speech, because when you have when you are talking, maybe you have some other sound, right? Or maybe when you're doing cooking, maybe you are talking, right? So you have both voice and environmental sound. So we try to separate them using the microphone array. We can separate them. But if you only have a single microphone, it's very difficult, almost impossible to separate the event sound and the speech. So then based on that, we can recognize the sound event. To understand the sound event, we create a database. So we need a sample, right? We need a database of the labeled sound. And then we can use a human labelers to provide those labels. And then you can use all kind of machine learning algorithms, including deep learning. So you can understand the sound. So what is that sound, right? So it's a toilet flushing sound, or it's a falling sound, or it's a cooking sound. So you can distinguish that. So this is our framework. Now here I show you some example here. So if this is an environment, right? So you hear some sound. Let me see if you can hear that. Can you understand what's that sound? Can you recognize? So this is another sound. So you have 3 sounds here. Let me play this one. Okay, anyway, so if you just listen to the sound, maybe it's very hard to understand what's that sound, right? But if you know this sound comes from here, or this is in the toilet area, in the bathroom, then you can recognize, or that sound is maybe the toilet flushing, right? And or maybe I think maybe I'm playing the wrong sound. This is the go back. Yeah, so what I want to say is this: if you're washing the hand here in the kitchen, or like washing your vegetables in the kitchen versus you're washing your hand in the bathroom, they sound similar, right? So, but if you don't have that context information, it's very hard to distinguish these two events. But if you know he's here or he's here, then you can easily tell apart these two sounds. So that's the basic idea. So that means we need the contextual information. And what is the contextual information? The location, where you are in the room, in the house, right? So this is the basic idea. So in order to solve this problem, we produce this framework called as a sound-based human activity monitoring framework. So basically, it's a sensor fusion problem. You have location information provided by the distributed sensors, because we have those infrared sensors on the ceiling, and you can tell where he is right now. He's in the kitchen, or he's in the bathroom, or he's in the bedroom. Then we also have the sound information. So you have two channels of information, and you want to fuse them together to figure out what he's doing. So that's a sensor fusion problem, and we can use dynamic Bayesian network-based approach to solve this problem. And then we use some up-level processing, post-processing to figure out what he's doing, what's his daily activity, or he's cooking, or he's using the toilet, like that. And also we can provide some measurement of the performance of this recognition. So this is the definition of this concepts. So we have sound events. From sound events, we can recognize the action. From action, you have multiple actions. You may have an activity, right? For example, the activity of cooking may involve multiple actions. You go to the refrigerator, you open the door, you take out something, you chop something, eventually you fry something, like that. So you have a sequence of actions. So in order to provide the location context, we use this called PIR sensors. So this is Arduino-based microcontroller, and we connect this PIR sensor to the Arduino, and it's a wireless sensor network. Then you can send the data to the robot, so the robot can figure out where the person is. Okay, so next, so here is called the post-processing. If you understand the event, right, sound event, then how do you figure out what is activity, right, or activity? So we try to do some post-processing, and here we have some results, right? So you have some sound data collect here. So here you have 3 sounds: brushing teeth, brushing toilet, washing hands, and those are the recognition performance results. So we did some experiment. We had, I think, 44 sounds here, and have collect from different rooms. And this is the performance, the sound event performance. And you can see the yellow one represents our method, and the HMM-based method is the red one. This is the state of art. And this is the blue one is without a contest. So apparently with contest, you can improve the accuracy, right? Because you have more information about the daily activity. Then we have some results for the activity recognition, right? The previous one is a sound event. Now this is the activity recognition performance. And we can jump to the video soon, so you can see that, right? So here we can see, based on that recognition, you can develop like a fall detection and the rescue application. So the robot will listen to the environment if the robot detects any falling sound, and the robot can, start moving toward the old adult and asking, are you okay? Like, or do you need me to call someone? So this is called fall detection and rescue. We did some results in the lab, and you can see this student is doing, it's simulating, right? We don't have real adults. It's very risky to do that. So we use the graduate students to simulate the falling, and the robot reacts to move to the spot where the person is found. So I have this video. Hopefully I can play it. So we can jump to here. So this is the environment we discussed. So he gets up, in the morning from the bedroom. So this is a real-time recognition results. So 15 means brushing the teeth, brushing teeth. Right. Then he's simulating the using of pilot. So this is a pilot flashing sound. So the sensors on the ceiling, I think maybe it's not here. This is the motion capture system, which provides the ground truth. Also, we have seating. Yeah, here we have the sensors on the ceiling, which provides the simple like on-off kind of output, which gives you the location information. So he is cooking or maybe boiling water, and we try to recognize that sound. So I can jump a little bit. So he's eating. Of course, this is a little bit exaggerated because when you eat, usually the sound is very weak. So we instead we use a speaker to play out the sound. So this is a falling sound, and this is a kind of abnormal behavior, right? Or abnormal activity, and you have to respond to that. Yeah, so that's the basic idea. So this is a case study of the overall framework. So the second part I want to discuss is called behavior well-being assessment through clinical interview. This has three parts: cognitive assessment, fall risk evaluation, and the pain rating. The idea is like this: we want to use the voice recognition capability of the robot and the natural language processing. We try to have some conversation between the robot and the old adult, and you can do some clinical assessment, right? We call it well-being assessment. So basically, you ask him questions. For example, in the previous case, if the robot detects that person is falling on the floor, the robot can ask, "Are you okay?" Right? But you can extend it. You can also ask him, "Do you feel the pain? What's the rating of your pain?" And also you can do cognitive assessment as well. So what is cognitive assessment? It's just like to evaluate your cognitive capacity through questions and answers, right? So you can check the memory capability of the old adult, or you can check his orientation capacity like that. So this is a real scenario.
Hi, Kathleen.
Good, how are you?
I'm doing well, thanks for asking. I'd like to ask you some questions about your memory.
Okay.
Right. Listen carefully. I'm going to say 3 words. You say them back after I stop. Ready?
Mm-hmm.
Here they are. Milk, sensible, before. Now repeat those words back to me.
Milk, sensible, and before.
Now keep those words in mind. I'm going to ask you to say them again in a few minutes.
Okay.
What day is today?
Monday,
What is the year?
2015.
Yeah, so I would just jump
What were those 3 words I asked you to remember?
in. So this is in real, word, how doctors, right, interviewed the patient and do the cognitive assessment, or we call it cognitive orientation assessment. So the question is, can we do it with a robot, right? Can we replace a doctor with a robot, or maybe a nurse with a robot? So this is our framework. So we have this robot in the home, and it talks to the old adult through question and answer, and then you can report back the results to the doctor. So the doctor does not need to come to your home to do this, or the nurse does not need to come to your home. So this is the overall framework. It involves conversation management, speech recognition, natural language understanding, also some vision capabilities like facial emotion recognition or face recognition. And you have to also be able to access the database provided by the doctors. Also, we have this interface on the screen. You can also use a touch screen to assess all the doctors' cognitive capacity. Also, like for the pain rating, you need to provide the number, right? Number rating, and also you need to find out where you feel the pain through this touch screen. So we did some tests with the real human subjects. We recruited 30 local older adults. And this is in collaboration with Dr. Bishop from Human Science. We conducted this human subject test a couple years ago. And you can see we provide different kind of questions. And we find out the robot can score almost very close to the real human subjects, real human practitioners or nurses. So the blue one means the correctly answered, scored answers. And also we have the accuracy regarding the face recognition, positive facial emotion recognition, negative facial emotion recognition. Although it's very challenging, you know, even for a human being, it's very hard to read other people's emotion, right? So that's why it's still not very good in certain categories. So we have this video. Let's see, we can.
Assistant. So please call me Elsa. I work as an elderly life smart assistant. So please call me Elsa Robot. This video shows my capabilities of elderly care. Currently, I can provide companionship through verbal conversation, entertainment, fall detection, video call for assistance, and clinical screening interview.
What is the weather?
Right now, it's clear sky and 52 degrees Fahrenheit in Stillwater. The humidity at 34%.
Tell me a quote.
Here is a quote of Francis of Assisi. Make me an instrument of your peace. Where there is hatred, let me sow love. Where there is injury, pardon. Where there is doubt, faith. Where there is despair, hope. Where there is darkness, light. And where there is sadness, joy.
Rock, paper, scissors. Great job. You defeated me. Play again. Rock, paper, scissors. Nobody won.
Congratulations, you won 3-2. Welcome to the robot-based cognitive evaluation. I am going to ask you some questions. First, I would like to ask you some questions about your memory. Please listen carefully. I will say the name of a person, the address, and city. John Black, 52 Tulsa. Now repeat the name, address, and city to me 3 times.
John Black, Tulsa.
Please remember this address. Later, I will ask you to repeat it to me again. Now think about time. What time of day is it?
It is 10:15 a.m.
Now think about where you are now. What state are we in?
Oklahoma.
What type of building are you in?
Oklahoma State University Human Sciences Building.
Recall the address I told you earlier.
John Black, 52 Main, Tulsa, Oklahoma.
Now, please pay attention. I'm going to give you a series of numbers. I would like you to give them to me backwards. 5, 3, 1.
1, 3, 5.
Yeah.
8, 7, 1, 4.
Okay, so this is
4, 1, 7, 8.
Yeah, so let's jump. Yeah, so this is drawing the hands of the clock. This is the one part of the standard test, I think, in real life.
Now, please let me know about your pain. I want you to rate your current level of pain on a scale from 0, no pain, to 10, worst possible pain. What is the level of your pain?
3.
Please give her a touch the face that best describes your current level of pain. Now, take a look.
Yeah. Okay, so yeah, so this is the test. So now I can show you some other functions which we recorded as a video here. It's more like a chit chat. It's like a
Hey, Elsa.
companionship.
Let's talk.
Now let's begin.
Nice to meet you.
You too.
What are you doing?
Just standing by, ready to help.
Okay.
Hooray.
How old are you?
I'm a bot, so I don't have an age.
Who is your father?
I don't have a family the same way humans do.
Do you have a boyfriend?
I don't have romantic relationship, but I do love helping people.
I'm hungry.
Eat food. Problem solved. Man, I'm good at this.
Do you
So,
eat?
so this is just a random chat, chit chat.
Hey, Elsa. Let's talk.
Second one is translation. We found that maybe
Hey, Elsa.
it's really in certain
Introduce
situations
yourself.
you need this kind of service.
Hi there. I am a companion robot developed at Oklahoma State University. I work as an elderly life smart assistant. So please call me Elsa Robot. I can provide companionship through verbal conversation, entertainment, cognitive assessment, call detection, and video call for assistance. I can also help you to translate from which language to which language.
Translate from English to Spanish.
Now let's begin.
Hello, nice to meet you here.
Hola, encantado de encontrarte acá.
I think the translation function would be very useful.
Creo que la función de traducción se usaría mucho para.
Okay, yeah. I don't know if it's correct or not.
Hey, Elsa.
Anyway, so the last piece video is, I think, the medication reminder. It's a part of the simple intervention. So we develop an app on the smartphone. So you can connect this, the app to the robot. It's more like a, it's called a Telegram. I don't know if any of you will use that. So the robot has an account on the Telegram.
John need to take flu
And then
medicine.
you can just friend the robot, and then you can send whatever information you can send to the robot. Then you can set up the reminder, right? So the doctors can use this to,
8
or the
a.m.
nurses can use this
PM,
app
and
to
9
set the
PM.
reminder for the adults to take medication. So this is a,
Next Monday.
yeah, so this is the interface on the nurses side or the caregiver side. Then
Pills, did you take it?
No, I didn't.
You need to take medicine on time. I will remind you 20 seconds later.
yeah, so okay, so that's the video. Oh, we have one more. I think we have one more function. Other function. This is more like a random function. Like tell a joke.
Chuck Norris's beard can type 140 words per minute.
Hey, Elsa. Tell me about COVID-19.
Coronaviruses are a group of related viruses that cause diseases in mammals and birds.
Yeah, since I'm running out of time, so I have to jump through it. So you can post the image on the Twitter account. Ask a robot take an image, right?
Hey, Elsa.
Take a photo. Remote caregivers can control the robot to take a photo in case of emergency. Okay. So I think I have to wrap it up, right? So basically, the conclusions is like that. New technologies are being developed to help older adults in their own homes when they age in place. So we believe the robots can take up many tasks, right? As we have demonstrated, although they are still in the kind of, basic, the very fundamental stage. But I think in the future, they can take up many tasks. So we developed this robotic assistant, which is able to do clinical interview, cognitive assessment, companionship, and fall detection. Hopefully, this robot can really help older adults live a better life, especially, to improve their mental health. Through our test, we found out the older adults interact with the robot, it really improved their social well-being, and at least their emotion was kind of improved based on the interaction with the robots. And so I hope this kind of social robots can be accepted by the elderly population in the future. And also we have some future research directions. So first we need to improve the human-machine interface. We find out, the older adults complain that the robot is really like a machine. It's not like a real human, right? So you need to give the robot a kind of facial expressions to make it more like a human-like, called personalization. That is called human-machine interface. This is a very challenging issue. How can you make a robot really like a human, right? So humans have emotions, expressions. Robots, can they achieve that? The second is privacy. This is also a big issue, right? People are complaining Alexa is violating their privacy because they thought or they think the Alexa is collecting their voice or their sound in the environment. So how we can address this issue, especially in robots, right? When you have cameras, that's definitely even bigger issue. You have to address that. So we were thinking about maybe in the future you need a robot certifying process. Before you sell the robot, you need to get a certificate showing, oh, this robot is able to protect your privacy. It will not, cause you too much concern. And next is the learning. How can the robot adapt to different environments? How can the robot learn new skills in elderly care? And the robot should be able to do it by itself, not always like programmed beforehand. And then the last one is scalability. How do you scale up to many robots? If you have a community of robots, say you have 50 robots, 100 robots, how can they learn from each other? How can you deploy, manage, and service these robots? There are many issues. So that's all. I think I would like to thank the National Science Foundation and also my collaborators, at least here, some of in my department, some are from the College of Human Science, including OU, Health Science Center, and my graduate students, especially Hadu. He's currently in another university as a postdoc. So that's pretty much I have. I'm just, I think, 5 minutes late, right? Okay. Any questions?
Yeah, thank you, Dr. Sheng. I thought that was a pretty insightful presentation. And I was particularly impressed by the fact that you're not using cameras, right? You're using some kind of, you're using sound localization together with contextual information to do your, do the classification of the sound to know where the adult is and to provide help where there was a need to provide help. So at this point, the floor is open. You can ask your question by unmuting yourself and asking your question, or you can also type it if you want, and I can read it out to Dr. Sheng. So the floor is open now.
Oh, hi, Dr. Shen. I have a question. So
Sure.
I'm Bing Yao from IEM department. I'm a new assistant professor here. Thank you very much for this very interesting talk. I have a questions like, so in the smart home, in addition to the audio sensors, you like I noticed in the slide at the very beginning, you also have like some medical sensor, for example, like the ECG sensors. So have you like consider like to combine the information from those sensors, like the wearable sensor with the audio sensor, and to help the robot like to maybe better detect anomaly like the fall or some other anomalies? I'm just curious.
Oh, yes, yes, that's definitely a good question. Actually, we are doing this already. Here, I presented only, the fusion between robot sensors and the motion sensors on the ceiling. But we also have wearable device, right? So the wearable device can provide you the motion data like acceleration, gyro, those kind of data from the human body. So that definitely gives you more information, right? So in sensor fusion, if you have more information, it's always, I think it's better, right? Usually it's better because you have more information to figure out what he's doing. So right now we are developing called collaborative sensing or perception between the robot and the wearable device. We recently submitted a smart health proposal to NSF. So we have a wearable device which collects audio and video as well. And we try to also the motion data, the acceleration data. And the benefit of the wearable device is that no matter where you go, you always have the data, right? But if you don't have the wearable sensor, if you only have the robot sensor, then if the robot is in one room, you are in the other room, the robot may not be able to hear you. That's the issue, right? So we also have a speaker microphone. So this wearable device actually is really important for the robot to talk to the adult, because you are in another room, you want to talk to the robot, you need this device. Otherwise, the robot cannot hear you and you cannot hear from the robot. So we also added other sensors, sensing modalities into this wearable device. So that makes the robot sensing capabilities ubiquitous. Ubiquitous means no matter where you go, you get the data, which is important. And also you can do sensor fusion. You have multimodality sensor fusion. You have motion data, you have sound, you have camera, and you have robot's camera. Usually we don't use the robot's camera. We use the robot's audio data, the microphone. So how do you fuse those sensors together? Right? Also, you have this power issue. The wearable device, you really is constrained by the power. You have limited battery resource, and you have to save the power, and you want to do it more like efficiently, power efficiently. So that gives you a lot of challenges. So we try to solve.
Yeah, the mobile, like the battery issue, it's truly a very like a challenging issue. Actually, I have just published a paper. It's about like ECG, constrained ECG sensing, which is like to develop an optimal like sensing strategy to like better use the battery life, like to under the constraint of the like the battery. So yeah, maybe we can talk more about it.
Sure, yeah, that's very interesting. I'm looking for any expertise in this area. So yeah, we can discuss later about this.
Yeah, thank you very much.
Thank you. Any other questions?
Yeah, I'm still waiting to see if somebody has typed in anything, but I don't see anyone typing. So again, whilst we wait for someone to ask a question, I can ask my own question. So I saw you got participants, about 30 of them, older adults. Was it difficult getting them from the Stillwater area?
How to like recruit older adults?
Yeah, to recruit the older adults for your user study.
Yeah, that's really challenging. But I have a collaborator, Dr. Bishop from Human Science.
Oh, okay.
So, yeah, they have like outreach programs. They have different kind of programs in their domain. Human science. They are supposed to study humans, right? So they have a lot of connections. So I worked with him, and that's an advantage. I take that advantage. So they help recruiters old adults. I work with him, and they have like a lab, and we did the test in their lab. We took the robot and brought the robot to their lab, and the old adults came to their lab, and we did the experiments, the tests there. Yeah.
Okay.
Yeah, sometimes it's really important to have real human subject tests. Otherwise, you cannot find those problems. You cannot improve the robot. You need a real human subject test, and you can find all kind of problems.
Yeah, that's true. I mean, again, given the challenge that this is a special kind of population, right? So, I mean,
Yeah.
you have to be very careful.
You need to be careful because you need the IRB approval.
Yeah, I was going to go to the IRB and ask.
They are older human subjects, older adults, right? So you have the risk if you want to do some experiments. That's dangerous. You should think about that.
Okay. Are there any other questions? I see. I don't see anyone asking a question. So we still have some 3 minutes, right? So
yeah. So if any of you are interested or have a question later, you can just contact me, or you can maybe visit my lab in the ATRC third floor. You're welcome, and we can discuss collaboration or just have some conversation regarding this topic.
Sure. Okay. So I think in the absence of questions, I would like to thank Dr. Sheng again for this presentation. I really did enjoy it, as I always did anytime I listen to you. And this is recorded, so you can always watch it too after this to at least get some of the points that you missed during this talk. And we look forward to some possible successful collaborations in future. Thank you again, and have a very good rest of your day. Bye-bye.
Well, thank you all, and thank you all for attending this my talk. Thank you.
Okay, all right, bye-bye.
Bye-bye.